This is Arvind Kulekar from Dr. Babasaheb Ambedkar Technological University, India. I am presenting a paper on software layer recovery through ego network analysis. In this paper, we have addressed the problem of software layer extraction, and we used a method called ego network analysis from the theory of social network analysis. So this is the agenda for the presentation. First, I am starting with the motivation, why we think software architecture recovery as a significant problem, and why we should use ego network analysis. Then we define the approach and present the we define the problem and then define the approach. We also evaluate the presented approach with our errors, with some of the earlier approaches in the that we found in the literature. Finally, we conclude with the summary of my presentation and some directions to the future work. So this is the agenda for the presentation. Software layer recovery is a significant problem because layering is one of the most commonly used architecture styles in software system, that is basically used to decompose software system in different modules, what we call it as the layer. And this high level information is useful to communicate the system functionality to different stakeholders of the software system. Layer mapping is required to analyze modular organization of software system. Certain kind of analysis can be performed to evaluate quality in terms of layering violations, such as skip call and back call. Most of the times, any business softwares are typically decomposed in three different parts, that is called as the data access, business logic, and user interface. And when these three different modules are executed on three different platforms, it becomes a three-tier architecture. We have used a analytical method to call ego network analysis from the theory of social network analysis to solve the layer recovery problem. And the theory of software network analysis provides a generic framework to analyze the structure of complex systems. Complex system is expressed as a network of nodes and edges. The theory of software network analysis includes a rich set of measures, models, and methods to extract the patterns of interaction among system elements. Most of these measures provide a highly intuitive and computationally simple way to analyze interactions when the system is represented in terms of a graph. Why we have used ego network analysis? Basically, because ego network represent a hierarchy of software system centered around the most significant or the core program elements in an application. Further, it intuitively represents the structure of a general system, including the software system, and it will be challenging to represent the architecture recovery problem in terms of ego network analysis. So these are some of the reasons that we have selected ego network analysis to address the problem of software architecture recovery. Here the layer recovery is defined as like this. We are defining the software layer recovery in terms of object-oriented for an object-oriented system. In an object-oriented system, program elements like classes and interfaces are related with different kinds of relationship, that is association, inheritance, realization, dependency, aggregation, and composition. And these layers and program elements are transformed into high-level coarsely granular modules related basically through a dependency relationship, and that transformation is called as a layer recovery. In comparison with the software implementation, the module is a coarse granular program elements. The research objective of this exercise is to extract high-level layering information, a form of architecture description from the implementation of artifacts like classes and interfaces, so that software architects can perform the analysis specific to the architecture style. Our objective is to define a lightweight architecture recovery approach that approximately represents a system decomposition in terms of coarse to granular units. The proposed recovery approach has three stages. First stage is called as the extraction. A dependency network is extracted. Here, a dependency network is defined in terms of software dependency relationship is extracted from the source code to create an ego network. What does it mean by ego network? We are going to see. Then the layer generation, the ego network is processed to generate layers, and the next step, the third step, is called as the layer optimization. The layers that are extracted in the second step are not optimized. In the third stage, the number of layers are reduced, and it is the system optimized representation of software implementation. Here I am presenting some of the basic terminology that we are using in the presentation. Ego node is a focal node in the personal network. Here I have represented one simple system consisting of 7 different nodes related through different dependency relationship. Here nodes are 1, 2, 3, 4, 5, 6. These are numbered like this, and basically these are the program elements. Like in the object-oriented system, these are the classes and the interfaces, and the arrows may be in the implementation or extends relationship or imports relationships. And this is the representation of a simple system with seven different nodes and classes. Here the ego is a focal node. A focal node, any node. It may be first node, it may be second node, or any node. In a personal network, for example, an ego node may be any node labeled from 1 to 7. Ego network is a personal network of ego formed through its immediately connected neighbors. And ego network for node 3. Suppose that this is the node 3. Its ego network is represented here like this. The ego network are nothing but the number of the directly connected nodes and their edges. Like for example, the node 3 is directly connected to the 4, 1 and 2. So these three different 4 different nodes forms a ego network. The ego layer is a layer consisting of only ego node. Here this is the ego layer, and ego layer structure has always 3 layers. The middle layer always consists of an ego node like this, and the nodes connected to the ego node with an outgoing edge accommodate to the top layer. So fourth node is in the top node, and node 1 and 2 are in the lower layer. So this terminology we are going to use here. The main focus is the ego node means any node in the system. Ego network is the consist of edges and nodes that are directly connected through the ego node. Ego layer is the consisting of only ego node only. So this is the terminology that we are using in the presentation. Now, layer recovery problem can be mathematically formulated as like this. Here the system is represented in terms of vertices and edges, and vertices are nothing but the program elements, and edges are nothing but the object-oriented relationship. And partitioning this program node in distinct layer is called as a layer extraction. Now, the first step in the layer recovery is the creation of ego layers, and how it proceeds. I will first explain, and then we'll give the algorithm for this node. So creation of ego node proceeds like this. We can randomly select any node. Here we have selected node 1, and to this node 1, the edges that are the number of edges that are connected with the incoming edges are kept at top layer. So these are the only nodes that are second and third are the only nodes that are connected through the incoming edges to the node 1. There is no nodes are connected that are related to the outgoing edge. So this ego layer has no lower layer. Now let us consider another example. For example, we can select the node 4. Here the 4 node is the ego node, and this is the ego layer. And the nodes that are connected to the outgoing edges are placed at the lower layer, and the nodes that are connected with the incoming edges are connected at the top layer. Similarly, for node 7, the nodes that are connected to the outgoing edges are connected to the lower layer, and on the 7th node there is no incoming edge is present, so there is no top layer is present. So by this way we can extract a ego layer for all the nodes that are present in the system. And this is the algorithm for the extracting ego layer, creating ego layers. The complexity of this algorithm is O to n or linear complexity, where the n is nothing but the number of nodes present in the system. Now, once those layers are extracted, the next step is called as the merging of ego layers. In the merging of the objective of the ego merging step is that to eliminate the duplicate layers. Here, what we do is that here first we take into consideration any random node, and we extract the layers structure for that. So see here the 7th is the randomly selected node, and this is the ego layer structure for the 7th node that we have extracted in the second step. Then another random node that is selected, and its associated layer architecture is taken into consideration. Here the random node that are selected here, the 6 and 5, and when the 6 and 5 are present in this node, then the 6 and 5 are present in the considered layer is present as a lower layer. So these two are merged here, and the new layer comes here like this. So this is the merged architecture. Now these two different layer extracted layer structures are merged here. Similarly, here this extracted layer again is considered, and the the layer structure associated with the ego node 4 is taken into consideration, and if its upper layer is combined with this, then this structure is become like this. So say this process gives us a removes the duplicate layer and gives us a layered architecture having n number of having the number of layers that are equal at the most, that are equal to the diameter or the depth of the network. Check here in the first diagram when we have seen the depth of this structure graph is 1, 2, 3, 4, 5. So here the number of at the most we can expect it the 5 layers, 1, 2, 3, 4, 5. So the after the merging stage, the number of layers that we extract are at the most the diameter of the graph or the depth of the graph. So this is the algorithm for the merging of ego layers. And once these ego layers are merged, our next step is the optimization stage. In the optimization stage, what we are going to do is that we are eliminating those layers having minimum number of nodes. Like for example, this layer has only one node. This layer has only one node. So while in the optimization, we are merging the layers that has number of nodes to less than a threshold value. This threshold value is calculated like this, where n is the number of nodes divided by d is the diameter of the depth of the graph, and in this case it becomes the 7 are the number of nodes and the 5 is the graph, so it becomes the 1.4. So any node that is less than 1.4 or the 1 or 2 that we are going to merge together. Now the 7 and 6 5 are merged together here, and 3 and 4 are also 4 and 3 are merged here like this. Now, when after merging like this, we are going to merge only those layers which will reduce the number of back call and number of skip call. The back call is the lower layer refers functionality from the upper layer, and the skip call is the skips the next adjacent layer and accesses the lower layer functionality. So while merging, we are going to take into consideration that the number of back call and the number of skip call gets reduced. So here in the once this by considering the number of back call and the skip call, these two layers are merged together, and final structure of this layer extraction is the two number of layers. The system is divided into the two layers. So this is these are the three different stages. This is the algorithm for the optimization of ego layer. So this is one of the sample case study that we have carried out on one particular software called Constore. This is the a graphics storage library, which stores the data as a graph. And this system is an open source system. We have extracted its architecture, and they are divided into three different layers: layer 1, layer 2, and layer 3. So this is the package dependency diagram, and this is the extracted layers. In order to evaluate our approach, we have compared our approach with four existing approaches. The first approach we are referring it as the BBA approach, which was published in Novel Approaches in Software Engineering Conference 2014. The second is the ozone method, which has been published in the journal Science of Computer Programming in 2013. And third approach, which we are calling it as the bunch, is published in ICSM conference to 1999. And fourth approach is Hub Auth, which has been published in year 2010. We compared our results with this approach, and we have used the parameters like precision, recall, and F1 scores, which are basically used when in the classification theory. Our approach, we got precision of around 0.92, recall of around 0.93, F1 score is around 0.92, and accuracy is around 90.91. The further we have evaluated the back and skip and cyclic calls in our violation in the extracted architecture, and this distribution of the program elements, number of program elements that are distributed in three different layers, that's the upper, bottom, and the middle. In our approach for the number of program elements that are distributed to the bottom layer are 3, 5, and 3. Then also the number of back call are 2, number of skip call are 5, and number of skip call are 2. For all these are for the Constore application. So our main contributions are like this. Our novel approach for software architecture recovery by constructing the ego network from the source code dependency is presented. We developed algorithms to create ego network and optimize it. We have demonstrated our approach on a small size system called Constore, and also executed it on different systems that are referred in the existing literatures. So unlike our earlier approaches, the attempt to search for the common, the earlier approaches tries to search for common similarity or patterns among program elements. We directly map the program elements into layer using the ego network analysis. The system is represented using a small network. It needs to be further evaluated for larger systems. So that is one in one way this work can be extended. Thank you.